Hi, I'm Shreya Jayaram, and this is my Physics 2211 Lab 5 about collisions. So, introduction. The purpose of my experiment was to create a computational representation to model the collision of two objects. The fundamental principles used in this experiment are Newton's second law, the momentum principle, and the conservation of momentum. The results of this lab show a computational model that is very similar to the data collected in the experiment. So the models I have are Newton's second law, which says that the final velocity is equal to initial velocity plus F net over m times delta t. The momentum principle says m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. The position update formula says position for the final position equals the initial position plus v times delta t, and the momentum is p equals mv. So, experiment. The initial conditions of the first bottle was an x position of 0 meters at an initial velocity of negative 0.852 meters per second, and the initial conditions for the second bottle was an x position of negative 1.748 meters and a velocity of 0 meters per second. The system is the two bottles, the table, and the earth, and the surroundings are everything else in the universe. As the video shows, the first bottle moves in the x direction and elastically collides with bottle 2, then stops moving, while bottle 2 starts moving with the exact same velocity as bottle 1. So this is my code. The code for this experiment has two parts, one loop before the collision and one loop after. The first loop, while loop, was set using the time until the collision and using only the initial velocity of bottle 1. The second while loop is the rest of the time with the velocities now updated to be the velocity of bottle 1 and bottle 2 after the collision. So as you can see here, they're initialized with the same mass, and then the initial velocity of the bottle 1, and then the position vector for bottle 1 and bottle 2, and then the initial velocity for bottle 2 is 0, and then this is the first loop to update the velocity and position before the collision, and then we have the reinitialization of the velocities after the collision, so bottle 1 is 0, and then bottle 2 is using the initial velocity that I got from tracker, and then this is the position and velocity updates after the collision. And this is the video from the glow script code. So as you can see, the blue goes until the green hits the green, and then now the green is moving while the blue stays stagnant. So discussion. Overall, the computational model I created for this experiment closely resembles the experimental data. I chose to calculate the force of friction for bottle 2 after the collision as it was a kinetic friction force that was simpler to find, but I omitted the friction force on bottle 1 since it was more of a static friction force that had to be overcome. So the graphs for bottle 2 look almost identical, but the graph for bottle 1 had some discrepancy. Another source of error could be from drag or other forces I chose to be negligible, or an inaccurate calculation of the frictional force. So as you can see here, bottle 2, the experimental and model are very close because I chose to add the frictional force here, but for bottle 1, the model is has a linear line for the x position, while the experiment has a more exponential line. So what if the force of friction I calculated for the bottle was applied on bottle 1, the graph looks to be exponential with a concave up curve. However, the experimental model showed a concave down graph in a logarithmic style. This could mean that the different kinetic friction forces, like static friction or drag, was acting on the bottle instead of kinetic friction. So what does it mean? Since the bottles have the same mass, the momentum principle and conservation of momentum say that the velocity of the first bottle could be the same as should be the same as the second bottle. This is true when you take the velocity of the first bottle in the midpoint, when it has overcome static friction and kinetic friction has not started acting on it yet. This velocity and the starting velocity of the second bottle are equal, which follows the momentum principle. In conclusion, I created a computational model that closely resembles an experimental elastic collision. I used the momentum principle and Newton's second law, and also calculated the force of kinetic friction to more accurately model the experiment. Thank you.